Aloha! Team Aina is proud to demonstrate Operation Ananas, a robot and drone duo designed to improve labor efficiency and optimize harvesting operations. To better understand the real-world challenges faced by farmers, Team Aina partnered with local farm Dole Plantation, gaining valuable insights to guide our design and software.
We started back in 1906. James Dole was the first guy came here, commercialized pineapple, and we've been here ever since. This is always recognized as the birth of pineapples here in Hawaii. In the early days, we used to have 271 people running the farm. We farmed 28,000 acres. Fast forward to present, we have maybe 150 people. We farm maybe about 2,800 acres. Nobody want to work in the farm anymore. The younger generation coming up, rarely.
The industry really needs to know how many fruit are going to be available, what the size is, and how uniform is the flowering within a given block. So here we have a block and it's about 3 or 4 acres. It can be up to 5. And they harvest about 10 acres a week. But what they want to know is, if you look at the fruit here, you can see different sizes. We would like to be able to predict that. We'd also like to be able to predict how uniform the flowering was. So if we can tell the percentage uniformity of flowering is within a week of each other, and what is the projected size of the fruit, this would be able to them to manage the operations in this field and also the marketing of the fruit.
To address these challenges, we developed a robot capable of traversing pineapple fields and calculating the volume of pineapples through 3D reconstruction. To complement this, a drone identifies flowered pineapples to optimize harvesting time. Together, these technologies reduce labor demands while enhancing harvesting efficiency.
To fit between tall pineapple leaves, the robot's frame was raised. Pineapple leaves typically grow up to 3 feet tall, but the Amiga only had 2 foot of ground clearance. Engineers swapped steel beams for aluminum extrusion, adding 20 inches of height. The PETG carbon fiber brackets and end fasteners were used to hold it together. The width was narrowed to 41 inches to move between plants more easily.
For the 3D reconstruction pipeline, we input the robot footage into ColeMap to get the dense reconstruction. We then import the dense reconstruction into MeshLab for mesh processing to isolate the pineapple body. We then compute the convex hull of the pineapple body and use geometric measures to get the final volume.
For the stitching process, we used the OpenCV2 library. Here is a breakdown of the algorithm that we developed. The process starts by using orb feature detector to find key points between 2 images. The red circles here indicate a feature. Using k-nearest neighbors, we can find similar key points in either image. The lines are drawn across the images to showcase which features are the same in either image. Using this information, we use Ransack to calculate the homography, which gives us the transformation of one image to the other. This can be used to blend 2 images into one, giving us the stitched image.
Once we have our stitched image as shown here, we can begin by running our object detection model for pineapples from RoboFlow, which should give us an output like this. Bounding boxes are then drawn over and a count statistic is assigned to each box based on how many pineapples were detected in that box. Taking boxes which contain only the pineapple field, we can now use the count data to produce a statistical measure of our model's performance. We can use metrics such as the root mean squared error and use the mean and standard deviation of every box.
From computer vision and robotic perceptions perspective, I feel the student has done an excellent job building a intelligent computer vision-based system that can take in the imagery input from the drone data as well as the land robot data and quantitatively answer some of the key questions that pineapple farmers are interested in, such as the flowering rate as well as the fruit sizes. I believe such system can be easily be scaled up to other different crops or to other different farms.
Ultimately, our goal was to address labor shortages by enhancing harvesting efficiency in an industry facing a diminishing workforce. The project utilizes advanced robotics and aerial imaging technologies to tackle challenges that farmers encounter, such as inconsistent sizing and blooming times for pineapple flowers.